This is my reassessment for work energy with potential. So a block with mass m hangs from a spring with a spring constant k. The block is released from rest a distance d above its equilibrium point. What is the position of the block as it passes through the equilibrium point, and what is the maximum distance below the equilibrium point that the block will reach? So I started off making a little diagram with a spring and a mass attached to it. Set our y and x coordinates, and d, put that down too. So create our system. System is going to be the spring plus the earth plus the mass. So our work energy total is going to be 0, and work is the change in kinetic energy plus the change in the potential energies. So the change in kinetic energy is 1/2 mv squared, mv final squared, minus 1/2 mv initial squared. mv initial is going to be 0 because it's released from rest. So our change in kinetic energy is going to be 1/2 mv final squared. Our change in potential energy is going to be the change in the gravitational potential energies plus the change in the spring potential energies. So our change in potential energy total is going to be mg y final, and y final is 0 at the equilibrium point, so that cancels out. So minus mgd, because it's a release from d, so d is the y point, plus 0.5 ks squared minus 0.5 k s minus d squared. Since s is the stretch, this is the final stretch at equilibrium point, and this is the stretch once it's released, s minus d. So we get 0 equals 1/2 mv final squared minus mgd plus 1/2 ks squared minus 1/2 k s minus d squared. So our final velocity once it reaches the equilibrium point is going to be the square root of mgd minus 1/2 ks squared plus 1/2 k s minus d squared over 1/2 m. So we have our velocity once it hits the equilibrium point, but now we need to find the maximum distance below the equilibrium point the block will reach. So we have our kinematic equation right here for the change in velocity. So our final velocity, I call that VF1, minus VF, this will be our initial for this equation, VF squared, equals to 2a change in y. So the change in y is going to be negative VF squared, so the negative of this squared over 2a.